Hello class, these are our notes for Algebra 2, Section 3.9, Solving Radical Equations. So I know we've been working on solving radical equations, but today we're going to look at some more complicated equations where when we solve, we get a quadratic that we have to factor and work with. We're going to look at things that have fractional exponents. So first we're just going to review extraneous solution. An extraneous solution is a solution that's created with the solving process, but it is not viable. So you've done everything right, you've done all of your solving steps correctly, but one of your answers just doesn't work in the original problem. So that's why we always want to make sure that we're checking in our original problem, even if you're not writing it down, even if you're just kind of looking at it and making sure it works. So when to check for extraneous solutions. This is going to be the long explanation, and then we'll look at the short one. So the domain of y equals cube root of x and any odd radicals. So that would mean like a fifth root, or maybe even something like a 2/3 power, right? That's going to be an odd root index. The domain is any real number. As such, solving such equations do not create extraneous solutions because you can have any real number for x as your input, you can get out any real number for y. So when we have to be careful is when we have something like y equals square root of x and any even radicals. So now think of like instead 3/2 power, right? 3/2 power, the top number would be your odd power, but the bottom number 2, so if we're looking at 3/2, we have an even root. So something like that, a square root, a fourth root, any of those are what we're talking about. Is limited as a radical only exists if the radicand, what is under the root, is greater than or equal to 0. So we can only take a square root if we have something greater than or equal to 0. So we could say 0 or positive. I don't know if that would make more sense to you. Or we could say greater than or equal to 0. When, during the solving process, you raise both sides to an appropriate even power, thereby removing the root, the result is an equation where the domain is x equals any real number. And when you change the domain, you can get extra answers that might not work. So how to check? Substitute into the original equation to see if it's true or not. Basically what we're saying is check your original equation when there is an even radical. So again, even radical could be like a square root. Remember, we don't have to put the 2 there, a fourth root, or even something like a 3/2 power, because this is even as well. And that's my root index. So steps for solving radical equations. So this is kind of the same steps we've been doing. We are still isolating our radical. So on this particular problem, I would want to add 1 on both sides so that my square root is by itself. So now I have x plus 1 equals square root of 7x plus 15. The next step is to raise each side to the same power to remove the radical. So we have to think about what we want to use for an exponent. Cancel would work there also, but since this is a square root, we're going to raise both sides to the second power. So square both sides. So the square and the root would cancel, and we would be left with 7x plus 15. And then on the other side, I have the quantity x plus 1 squared. So I could go through and I could say, well, let's figure out x plus 1 times x plus 1. I could go through, that's what squared means, right? Multiply it by itself. You could do all of your distributing, or you could remember that I need to square my first thing. So my first thing in the parentheses is x. So that I would write down an x squared. The middle term is always doubled because I had an x times 1 and another 1 times x. So x times 1 doubled would be 2x. And then my last term would be the 1 squared. So that's going to be plus 1. So now I have an x squared. I want to think really carefully about my next step. So it looks like I'm going to have a quadratic. If I had x squared on both sides, I could subtract them and cancel it out. But I don't. I just have an x squared on one side. So I do have a quadratic. So remember, we always want to make them equal to 0 and then solve by factoring and using zero product property. So I'm going to want to have this equal to 0. So all in one step, I'm going to subtract the 7x and the, you know what, it looks like a 15, not a 5, and subtract the 15 at once. So I know I don't normally let you guys do this as one step, but because I know I'm trying to get a 0 over here, it's fine. So my new equation that I'm solving is x squared minus 5x minus 14. So now that I have my quadratic equal to 0, I can solve and do zero product property. It has to be equal to 0 to do zero product property. This is going to be x minus 7 times x plus 2 equals 0. And notice I'm still writing the equal 0. We can't just ignore that. We've got to write that down with every step. So now I have x minus 7 equals 0. I'm going to go ahead and solve this one. And x plus 2 is equal to 0. So I have two answers. So one of these might not work, right? That's the problem with squaring both sides. We could be introducing extra solutions. So I do need to check them both. So first I'm going to check x equals 7. So that means 7 goes into my original equation. This is my original equation. I can't even move the 1 over. It's got to look exactly like that. So I'm going to write 7 equals square root of 7 times 7 plus 15 minus 1. So this is going to be 49 plus 15. 49 plus 15 is the square root of 64. So 7 equals 8 minus 1. Check. That one definitely works. And now we're going to check x equals negative 2. So we're looking to see, does negative 2 equal the square root of 7 times negative 2 plus 15, that whole quantity, square root of that whole quantity, and then minus 1. So let's see. Negative 14 plus 15, and that's going to be the square root of 1. And the square root of 1 is just 1. So 1 minus 1 makes a 0. It does not make negative 2. So this is going to be an extraneous solution. And it looks like our only solution here is 7. So 7 does work. So there's going to be a lot more answer checking today. We're just looking at more complicated equations. The next one, I've got a cube root. So because I have a cube root and it's on both sides, I'm going to raise both sides to the third power. So we really like cube roots. We don't have to worry so much about extraneous solutions. It's still good to go back and check, make sure your answer works. But remember, the domain for these is all real numbers. So we don't have the issues we have. So when I cube both sides, everything cancels. We just have 2x plus 4 equals 6x minus 6. Let's go ahead and subtract 2x on both sides. So 4 is equal to 4x minus 6. Then I want to add 6. So I'm doing this one step at a time, only do one step at a time. Divide by 4. And I can reduce this fraction by dividing the top and bottom by 2. So I get 5 halves is equal to x. So notice I left the x on the same side all the way down. That's the kind of work I'm looking for here. All right, this looks great. On to the next page, we've got to check your understanding. This was really tricky for them in class, but you should try at least on your own. And then you could go back and watch, and I'll do kind of an explanation on this. So number 1, I can see my square root is kind of here, and I have a minus 2 on the same side. So I'm going to start out by adding 2 on both sides so that I have x plus 2 equals the square root of the quantity 2x plus 7. So at this point, my square root is by itself. It's around both the 2x and the 7, so to get rid of it, I would square both sides. On the left when I'm squaring, remember we've got to go through and do that whole like x plus 2 times x plus 2. So the way that I do that, my shortcut is to take x and square it. My middle term will be 2 times x but doubled, so 4x. And then the 2 squared gives me a 4. On the other side, I have just a 2x plus 7. So now I want to get everything equal to 0. So I'm going to subtract 2x, subtract 7, because I have an x squared. Whenever we have an x squared, we want to get everything on one side, 0 on the other, and we want our x squared to be positive. So now I can go ahead and factor. And we're going to take and do zero product property. Make sure you show all of your work on zero product property. All right, now that I have my two answers, I do want to check. So I'm going to check x equals negative 3. So could negative 3 equal the square root of 2 times negative 3 plus 7 minus 2? And this whole square root is just going to be 1 here. Negative 6 plus 7 is 1. So that's going to be 1 minus 2. It's not going to work. So this is going to be my extraneous solution. Let's make sure that 1 works as well. So I have worked these out where both of them work. You never know. You just have to check. 2 times 1 plus 7. So let's see. 2 times 1 plus 7 is 9. So square root of 9 would be 3 minus 2. So this one works. 1's going to equal 1. So we can go ahead and box in the x equals 1. So that's generally what I do, is I just go back and like draw a line through one equal sign and box in the other one. And that shows I've looked at both of those solutions and I found which one's correct. Next one's a little bit tricky. We need to take both sides to the fourth power to get rid of a fourth root. And we go through and we do all of our solving. So this is one where I would not do a bunch of steps at once. The 2x is smaller, so I'd want to subtract 2x on both sides. Negative 6 equals 2x plus 18. And so the mistake I see on this one is people see the minus 6 and they want to add 6 right away. But that's not what I want to do here. I want to subtract 18, right? Because I want to have x on one side, numbers on the other. So that's a negative 24 divided by 2. X is negative 12. But remember, whenever we solve something that is even, an even root, we've got to be really careful. Check our answers. So this would give us the fourth root of 2 times negative 12 minus 6 equals the fourth root of 4 times negative 12 plus 18. So negative 24 minus 6, fourth root of negative 48 plus 18. So on both sides, I have the fourth root of negative 30. This is a really tricky problem, and there's people that want to argue every year. So my issue is that they match, they're equal on both sides, but there's also no fourth root of negative 30. So this is going to be no solution, and you are welcome to argue that. I think it's a really fun kind of thing to think about. So while it's equal on both sides, because the fourth root of negative 30 is not actually real, I don't have a real solution. It doesn't really work. All right, on to the next section, solving equations with radical exponents. Rational exponents. So we want to check for extraneous solutions if the index of the radical is even. And that's what we kind of talked about on the last one, right? A fourth root was even. You get two solutions, positive and negative root. These are just things to remember. You get two solutions, positive and negative root, if the original exponent is even. So this is when we do our absolute value, right? So if we have an x squared and we take a square root, we get an absolute value. If we have x to the fourth power and we take a fourth root, we get an absolute value. If I have x to the 2/3 power, like our top number there, it's even. So when I get rid of that, I'm going to have an absolute value. Okay? So anytime we have an even power, absolute value afterward. With rational exponents, remember that the numerator is the power and the denominator is the root index. And then this is just really quick to remember how these work. We could write this as the 8th root of x to the 5th power, or we could write the 8th root of x to the 5th. Oh, and I made that look like a 3. It should be an 8. So either of those would be fine. I feel like for evaluating, we normally do this one because we want to do a root first before we get a really big number. But sometimes it's easier to write it the other way. That looks better. All right, last page. So now we're looking at rational exponents. I want to isolate the part that has x to the 4/3 power. This is my thing that I want to get by itself. So first I would add 21. And then negative 2x to the 4/3 power equals negative 32. Divide both sides by negative 2. So I have x to the 4/3 equals 16. So I've done the isolate step. Now we want to raise each side to the reciprocal power. So the reason we want to use reciprocal is right now I have 4/3. If I multiply that by the reciprocal by 3/4, I get 1. So remember, with exponents, when we raise it to a power, that's power to a power. That's when I'm multiplying my exponents. So when I do that, I'm going to have x to the first. X will be by itself. Well, almost by itself. Because I have an even here, this is even. So an even power, so it's an odd root, but an even power. And it's not what I'm doing, it's how I started out with. Odd root. Because I have an even power, I need to have absolute value signs. So now I have absolute value of x equal to, remember we can think of this as the 4th root of 16 and then raised to the 3rd power. So x will be plus or minus. 4th root of 16 is 2, so 2 to the 3rd power, which is going to be a plus or minus 8. The last step is going to be to check for extraneous solutions. It says if the index of the radical is even. And it's not even here, right? The index of the radical is odd, so they should both work. But photomath actually thinks they don't both work, so it's kind of interesting. So let's see how these do work out. So if I have negative 2 times 8 to the 4/3 power minus 21, we're checking to see does it equal negative 53. So when I have 8 and I have a third root, remember, third root of 8 is going to be 2. So this is negative 2 times 2 to the 4th power. So that's going to be negative 2 times 16, which is going to be a negative 32 minus 21. So this one's definitely going to work. So what happens if we put an odd number in there? Or sorry, put a negative number in there? It's good for us to think through these things. So if I have an odd number, what's going to change is that when I find the third root of negative 8, it's going to be a negative. So I'm going to have negative 2 times negative 2 raised to the 4th power. So negative 2 raised to the 4th power in our parentheses like that, that's going to be a positive 16. So I'm right back to where I started, and there are going to be 2 solutions here. So I'm going to go ahead and box them both in. Like I said, photomath is not getting 2 answers on some of these. Please don't just rely on AI to do your math for you. Last one, I have a 3/4 power to start with. So that means we're not going to have absolute value because the 3 is odd, right? We're not going to have absolute value. But because it's an even denominator, we're going to have to do an answer check, right? That's when we have to do an answer check. So even root, make sure to check for extraneous solutions. The last one was even power. Make sure you get absolute value. Solutions. Okay. So first step is to isolate all the stuff being raised to that power. So first we'll subtract 1 on both sides. Then we have the quantity x minus 5 to the 3/4 power is equal to 8. And then I want to do reciprocal exponent again. So remember, reciprocal exponent, I can't even say it, is because we know that this would be power to a power. And so we'd be multiplying our exponents. And 3/4 times 4/3 is just 1. So now I have x minus 5 to the first power, which is just x minus 5. Because I have an odd power, I do not need absolute value signs on this one. So now I'm going to think about the third root of 8 and then raised to the 4th power. So the third root of 8 is 2. And 2 to the 4th power is going to be 16. And then I'm going to want to add 5 on both sides. So x is equal to 21. All right, last step, do a quick answer check. 21 minus 5 to the 3/4 power plus 1 equals 9. This is 16 to the 3/4 power. So this means my 4th root of 16, that's 2. 2 times 2 times 2 times 2 equals 16. So the 4th root of 16 is 2. So now I have 2 to the 3rd power. And this means I have 8 plus 1. So 9 is equal to 9. So this answer does in fact check out. All right, big ideas today, I think, is just anytime we have the even power, that we're getting the absolute value. So like that was a really big thing here, even power, absolute value around your x or your x plus whatever, right, your quantity. And then just kind of how to deal with these fractional exponents. If I have a 4/3, we have to use a 3/4 power on both sides. So I think that's a little bit tricky too. I also really like this first one where we had to go ahead and factor and solve and show all those work steps again. So as always, if you need help, please make sure you ask.